Hey everyone, welcome to this video lesson. Mr. Smith here. In this video, we're going to keep talking about parabolas, specifically what is the standard form of a parabola. It's another way that we write parabolas. As you see, there's parabolas everywhere in real life. You can see them everywhere if you just look in the right places. Balls traveling through the air makes a form of parabola. Roller coasters always have a parabola in there. Or this thing down here at the bottom, this is the Gateway Arch in St. Louis, which for some reason is it's like a famous piece of architectural work, but it's just a giant parabola. There's nothing really special about it. I don't really know why it's super famous, because it's literally just a giant parabola. But anyways, that's the Gateway Arch in St. Louis. So like I said, we are going to talk about standard form in this video. In the last video, I told you that there's going to be three forms of a parabola that we focus on. Okay, there's going to be three forms of a parabola that we focus on. In the last video, we did vertex form, right? In this video, there's going to be standard form. That's what we're going to talk about. And then there's a third form of a parabola that we'll look at later. I'm not going to spoil it for you. I'll just have to leave the enthusiasm. Okay, so we got vertex in the last one, standard form right now, and then the third form of a parabola we'll look at in the next video. So anyways, let's talk about standard form of a parabola. That's the focus for this video. Standard form of a parabola looks like this: y equals ax squared plus bx plus c. I'm sure you maybe remember that a little bit from Algebra 1. We're going to deal with this form of a parabola probably more than any other form, right? So standard form is going to be pretty routine for us by the end of this class. We're going to deal with it a lot, so we got to be able to we got to be good at it. We got to know how it works. We got to know all the pieces to it. So a couple things here, a couple quick hitters. If a number in front, the leading coefficient, if that's positive, the parabola opens up, meaning like that. Okay, so if a is positive, you're a happy parabola. It's smiling. It kind of looks like a smile. Okay, a is positive, you open up. If a is negative, you open down. So if there's a negative sign, you have a sad parabola. Oh no, we're frowning. Sad parabola. Okay, so if a is positive, you open up. If it's negative, we open down. The axis of symmetry. Remember, this was super easy to find in vertex form. All we needed to do was look at the number in the parentheses and flip the sign. In standard form, it's a little bit more involved. We have to use this equation, x equals negative b over 2a. It's going to be an equation that we use a lot. I'll show you how to use it down in this example. To find the vertex, remember the vertex is a point with x and y, and the x-coordinate of the vertex is your axis of symmetry. So once you have the axis of symmetry, which you get by using this fancy-dancy equation, you just take that x value, plug it into your original equation, and that will tell you the y-coordinate of your vertex. And I'll show you how to do that in just a minute. And the y-intercept, we won't talk about this a ton, but if you want to find the y-intercept of a parabola in standard form, all you got to do is plug in 0 for x, and that's just going to leave you with whatever c is. Okay, so your y-intercept is 0 with your final term as your y value. Okay, so let's dive into an example. Here's my function, negative 3x squared minus 6x plus 1, and I want to graph this thing. Right, it's in standard form, and I can see that because it matches this form, ax squared plus bx plus c. It's in that general form. It matches that skeleton. So I know I'm working in standard form. That changes the rules, right? That means I need to use these pieces of knowledge from up here. So first, let's find the axis of symmetry. That's going to be kind of step one in graphing these things. I need to know what my axis of symmetry is. Just remember, I got to use this equation, x equals negative b over 2a. So I'm going to write that, x equals negative b over 2a, and let's plug in those pieces. So a is the first term, b is the second term, c is the last term. We're talking about the coefficients here. So b is negative 6. So if I plug negative 6 in here, it's going to be negative 6, because I'm talking about negative b. But since it's already -6, I'm going to have two negatives there, okay? So I can't lose track of that. -6 over 2 times a, which is -3. So we got to just go slow if you need to. Don't lose track of your negative signs. Let's see what happens next. -6, that's +6. 2 times -3, that's -6. Okay? And 6 over -6, I can reduce that to -1. All right, so I just found out that my axis of symmetry is x equals -1. That's my axis of symmetry. That's the line that cuts the parabola in half. All right, now that I have my axis of symmetry, I can go find my vertex. Remember, that's the most important part of a parabola, most important point. We're going to use it a lot, so let's go find it. And remember, like I said, the vertex is a point with x and y, and your x-coordinate is your axis of symmetry. So what I'm going to do is I'm going to take the axis of symmetry, that x value that I got up here, and I'm going to plug it in to my original equation. Okay, so switch colors here. I'm going to plug it into my original equation. So that is, the original equation is y equals -3x squared minus 6x plus 1. I know that the axis of symmetry is -1, so I'm going to replace x with -1. Okay, so here's what it's going to look like: 3 times -1 squared minus 6 times -1 plus 1. So let's just do this one piece at a time. Think orders of operations. We need to do parentheses and exponents first. -1 squared is -1 times -1. That's just 1. I have a -6 times a -1. Negative times a negative is positive, so that's +6 plus 1. Okay. And 3 times 1, that's just 3 plus 6 plus 1. Okay. Oops, sorry, I knew I was missing something. There should be a negative sign in front of this 3, right? I knew I was missing something there. I forgot to write that negative sign. So, doesn't change anything up to this point. -3 plus 6 plus 1. Let's see what we get here. -3 plus 6 is 3, and 3 plus 1 is 4. So my vertex is the point. X is -1, and y is 4. Here's my vertex. That is the middle point of my parabola. Okay. Now that I have that, we can graph this the same way we graphed vertex form in the other video by building a table. So let's go ahead and do that. I'm going to get a table. Remember, big deal from the last video. One of the big things we need to do is always have vertex in the middle. Big rule for us. Vertex has to go in the middle. So vertex is -1, 4. And then we go 2 points bigger and 2 points smaller. Okay. And then if you remember from the other video as well, since a parabola is symmetric, I only need to choose half of these points to do. I only need to choose the top half or the bottom half. And then since it's symmetric, I can just copy those values to the other half. So pick the ones that look easier, right? Don't pick ones that are going to be harder. I would choose 0 and 1 here, because that's going to be way easier to evaluate than -2 and -3. If you like doing -2 and -3 because you like doing more difficult math calculations for fun, be my guest. But I want to take the easy way out. In this case, work harder, not smart, or work smarter, not harder, right? So I'm going to choose 0 and 1 here to plug into my equation. So let's do x equals 0 first. X equals 0. Okay. Remember, the equation is y equals 3x squared minus 6x plus 1. Well, this is pretty easy. If we plug in 0 for x, these two things cancel, because I'm just multiplying by 0, and I'm just left with 1. So if I plug in 0, I get 1. All right. And what happens if I plug in 1? Well, let's see what I get in that case. Here's my equation. I'm going to plug in 1. 3 times 1 squared minus 6 times 1 plus 1. We'll do it one piece at a time. 1 squared is 1. 3 times 1 is 3. Minus 6 times 1 is 6. 3 minus 6, that's negative 3, plus 1. And negative 3 plus 1 is negative 2. Okay. Oh, I did it again. Oh, no, I didn't. I got a negative sign there. Yeah. Negative 3. There we go. Okay. So, I get a negative 2 if I plug in 1. All right, so we do not need to do the bottom half here. All right, all we need to do is copy these numbers to the other side, and we're good to go, because I know that the parabola has to be symmetric. And since it's symmetric, one half of it should look exactly the same as the other. Sorry, guys, I just got an email in the middle of my video, so pardon that. Okay, so there we go. We plugged in our values. We got a table now, so let's go ahead and graph this. Okay. So at 1, I'm at negative 2. At 0, I'm up there at 1. At negative 1, I'm up at 4. At negative 2, I'm at 1, and at negative 3, I'm down at negative 2. So here's my graph. Okay. There we go. Okay. All right. Let's see here. How do I want to do this? Let's talk about a different case, okay? What happens if our b value is 0? Okay, what if it looks like this? Notice how this is a little bit different. Our standard form looks like this. I'm missing a middle term in this example. I'm missing a middle piece. There's no b value. There's no single x term, okay? If that's the case, don't freak out. Everything is exactly the same. So let's just approach this the same way we approached the last one. Let's find the axis of symmetry first. Remember, that's the equation x equals negative b over 2a. Well, b is just 0, because you could think about this equation like this. Y equals negative x squared plus 0x minus 5. That's the same thing as this, right? Just wrote it with a 0 in the middle, and that's perfectly fine. That actually shows me that b is 0. So if I'm going to find the axis of symmetry, I know that b is 0, so this is going like this. Negative 0 over 2 times a, which is negative 1. Well, negative 0, that's just 0. And then it doesn't really matter what's on the bottom, right? It doesn't really matter what's on the bottom, because 0 divided by anything is just 0. So I know that my axis of symmetry is going to be 0. So then to find the vertex, all I got to do is plug 0 into this equation for x. So I'm going to take x, I'm going to swap it out with a 0, since that was my axis of symmetry. It's going to be negative 0 squared minus 5. But again, that is not very interesting, because 0 squared is just 0. So that's gone. And I have 0 minus 5. So I just end up with negative 5 as my y value. That means that my vertex is the point 0, negative 5. That is going to be my vertex in this problem. Okay, the axis of symmetry is 0. I plugged it into my equation. I got negative 5 for y, so that gives me my vertex. Now we're ready to try to graph this. We need a table. X, y. Vertex goes in the middle. 0, negative 5. I want 2 points bigger, 2 points smaller. Pick the ones that are easier. So I'm going to pick the positive numbers. Okay. So let's do x equals 1. Let's see what happens. My equation is y equals negative x squared minus 5. So I'm going to plug 1 in for x, negative 1 squared. Okay. So that is going to be 1 squared is 1, but notice how that negative sign is on the outside of this squaring action over here. So since it's on the outside of it, that negative sign is just going to get attached to whatever I get after I square my number. I'm not squaring the negative sign. So it's going to be 1 squared is 1, and then if I put a negative sign in front of that, 1. Okay. Now let's do, see if I can do this. I'm bad at this like fancy erasing thing. Perfect circle. Oh, yes. There we go. Let's do 2 now. So I'm going to plug in 2. The equation is y equals negative x squared minus 5. I'll plug in 2 for x, negative 2 squared minus 5. 2 squared is 4, and then I smack a negative sign in front of that. So it's going to be negative 4 minus 9. And negative 4 minus 9 gets me negative 13. And let's see. Oh, I wrote the wrong number here, didn't I? Sorry guys, technical difficulties. Let's do negative 1 one more time because I obviously messed that up. This is why I need you guys in the room with me to keep me honest if I make a mistake. So if I plug in negative 1, sorry, if I plug in 1, negative 1 squared minus 5, negative 1 minus 5. Okay. And that negative 1 minus 5 should give me a negative 6. Mess that one up a little bit. Put in a positive 1. There we go. That's better. Sorry, my bad. Messed up plugging in 1. All right, so anyways, now that I get my top 2 numbers, I can flip these down to the bottom. Okay, and then I can go get my graph. So let's see what we get. 2, negative 13, that's off my graph, so let's just say it's down here, I don't know. 1, negative 6, right there. 0, negative 5, negative 1, negative 6, and negative 2, negative 13. Again, that's off my graph, so I'm just going to give it my best guess. We'll say it's somewhere in this area. And my parabola looks something like that. There we go. Okay. One more thing. If I asked you, does this parabola have a max value or a minimum value, meaning does it have a top or a bottom, simply by looking at the graph, you could tell me because it has a negative sign in front, right? That means the graph has to open down, which it does. And if the parabola opens down, the vertex is up on top here. I kind of like to think of this as a mountain. It's like we're coming up to the top of the mountain, and that's our maximum point. That's the highest that we get. So this graph has a maximum value, and that's because it opens down, right? In the same way, a graph that opens up would have a minimum value because it has like a bottom point, okay? So just keep that in mind if you get asked whether or not a graph has a maximum or a minimum value. You can figure that out really easily just by asking yourself, does the graph open up or does the graph open down? And then just picture what it looks like. Does it have a top? Is there a top to the mountain? Or is there a bottom? Is there a bottom? Is it like a valley? Or something like that, okay? All right, well, that's going to do it for this video. I don't want to keep these as short as I can, so that's going to do it for this video. Thank you for hanging with me, guys. And if you, at this point, if you are still watching, email me with a funny joke. Email me with a funny joke if you're still watching. It'll make me laugh. It'll make you laugh. Maybe not, but it'll make me laugh. So email me with a funny joke if you're still watching this. Thank you guys for hanging with me, and we'll see you next time.